Hey guys, welcome back to Trigonometry Revision for GCSE IGCSE, and we are on 3D problem solving. Here is the problem 3. I apologize in question A. So in question A, there were stated KL, but there was misprint because KL is definitely has 90 degrees. It's already shown here on the figure. So the actual question, you need to find actually the angle between the given line segment, and your line segment is KC. So KC is that one, so slant, okay? So, or basically the edge of the pyramid. Okay, so if you actually figure out that, okay, so it's cool. But if you haven't done that, you have the chance to do that right now. So pause the video, make screenshots, try to work by your own, and here is going to be explanation. All right, so we start reading the problem. So for the following pyramid, you need to find the angle between the given line segment, which is here, KC and KN in part B, and the base plane. So the base plane is here. It's A, B, C, D is the bottom part of your pyramid. Okay, so bottom part is actually a rectangle with sides 10 and 8 centimeters. So size mentioned here. All right. So first, let's try to figure out angle between KC and the base plane. All right, so one more time, I just want to remind you, if this is going to be the line segment, which is marked as red, and you shine the light vertically on that segment, so this is the light. I just want to clarify idea about the angle between the base and some inclined segment. So if you shine the light on KC, on the segment KC, it will cast actually the shadow. The shadow is going to be from the point L, from the tip point of K, and to C itself, because here C and the point with the shadow ends, they actually coincide, they match. So that's going to be the shadow from the light. So LC is called shadow, or normally in mathematics it's called projection. So LC is going to be projection. So the angle between the segment KC and the base becomes the angle between KC and its projection LC. So generally you need to find, I'll just clarify what sort of angle you need to find. You need to find angle KCL. Okay? That's what actually you're looking for. Okay, so how to figure out that angle? For that reason, you need to know something more, I guess. So, what actually you need to know? You need to know KL, the height of the pyramid. Or you need to know probably, let me see. Yes, or you need to know AC. It's better to use, if you need to figure out the angle, you need to know either KL or with LC, or you need to know KC, for example, with any other leg. So that's the tricky task. But what are you given? You're given angle BKC, which is 30 degrees. Okay, so what we can do, we can figure out first, let's try to figure out the slant height. Okay, I use the green one and put the slant height from there down away until it splits the BC segment in the middle point. So actually KN, where N is the midpoint of BC. So N is midpoint. So in this case, this angle becomes a 15 degrees angle, right? Why? Because right now you see that Kn is slant height in the pyramid, and slant height always bisect the angle, because your triangle KBC is going to be isosceles, so this is going to be that one. Okay, according to the figure, the pyramid is upright. Yeah. Okay, by the way, you see diagonals intersect and split into equal halves. Okay, it's not clearly stated here, but it's obviously seen from the picture. So in the problems, you'll be clearly stated about sides, which sides are equal, what sort of pyramid you're given. In this case, you need to have a look at just at the picture. All right, so let's go to the angle. We have angle 15 degrees, and what it allows us to do, it allows us having also the fact that n is midpoint, so we can figure out that bn equal nc, and each part is equal to 4 centimeters. So, and this is also the right angle because it's slant, right? So we can use triangle. So let's use triangle K and C. Let's do that. So K and C. What we can do within that triangle, we know that NC is simply 4 centimeters because KN bisect the segment, okay? And N is midpoint. So we know that. We also know 15 degrees angle, so we can figure out KC immediately. All right, so let's try to figure out KC. So this triangle is right angled, so we can figure out KC. So I just simply restore the image of that triangle. This is going to be KN, and other parts, so this is going to be KC, and the bottom part is going to be black, so this part is going to be NC. So that's for KC, oops, NC. Sorry, my bad. Okay, and that's point K. So we've got 15 degrees angle and side of 4. So we can figure out KC immediately. So we can use, in this case, this is the opposite side. So we can use sine rule. So 4 is actually KC times sine of the angle 15 degrees. So from where we can figure out that KC is 4 over, so it's 4 over sine 15. And we've got that KC is 15.45 centimeters. Okay, so we found KC. Just erase that light. Oh. Instead of erasing, first I need to highlight and ooh. That's really problematic here, sorry guys. Inconsistency of the software. So, okay, KC 15.45 centimeters. So, from where, if we know KC, in order to figure out angle KCL, which is here, let's mark as theta. Okay, so what we need to know? We need to know LC, for example, because for height, it's going to be really problematic. Yeah, it's better to find AC first. So from the triangle ACB, so triangle ACB is a right angle, is right at angle B. So angle B is going to be 90 degrees. This is a rectangle. And what we're going to do, we can set up that AC. If we know AC, we can figure out LC as well. So AC square root of 10 squared plus 8 squared. We basically use Pythagoras. So that's Pythagoras. From where AC is going to be, let's calculate. So hundreds, 164. It's going to be 12.81. 12.81 centimeters to 2 decimal place. So what about LC now? So LC is the half. So LC is basically half, right? Because diagonals in rectangles split it into equal parts in the middle point, in the point of their intersection. So LC is going to be half of AC. So that's going to be, just let's halve it, halve the value. It's going to be 6.40 centimeters. Okay, so we found LC. I just mark with that purple line, violet. Okay, we know LC, we know KC, and here we're going to use one more triangle, so it's going to be there. KLC, that's triangle that we're going to consider. Okay, that one. And what we have, we know that KC is here. We found it. It's 15.45 centimeters. We found it. And then we also found LC, which is here. And this is right angle. So we found LC, which is now 6.4. Okay, so we can figure out that this is 6.4. Okay, so we need to find angle theta. That was the first part of the problem. So what we can do, adjacent side hypotenuse. All right, so how to find? We're going to use cos rule because that's adjacent side. So cos theta is going to be basically 6.4 over hypotenuse, which is 15.45. Okay, so from where we can figure out angle theta as cos minus 1. Cos minus 1 of that fraction. And the result is going to be cos of the fraction 6.4 over 15.45. So the result is 65.53 degrees. So 65.53 degrees. Okay, so we found the first part of the question. So we figure out angle KLC, which is 65.53 degrees, and that's the answer for part A. Okay, so we figure it out. So what's next? KN, where N is midpoint. So we need to find the angle between KN and the base. All right, so let's have a look here. So where is KN? KN at that segment, it's a slant height, right? And LN is going to be the shadow for that. So what we're going to do, we just simply need to put the line here, let it be also green line from there to there. And we already know the length, right, for LN. So the length for LN is simply half, right? So we can say that. So this is part B, and we're looking for that angle. So if you like, I can drop triangle, which is right angle that we have for that case. Okay, this is triangle. We set up vertices K and L. So L is right angle in this case, and we're looking for that angle. Let's put angle L for degrees. So Greek letter stays for angle. So we know that LN is simply half of AK, because that's definitely half, right? LN is going to be 5 centimeters. Do we know height now? Do we have kn? Yes, we can find that if we don't know. Yes, we don't know, but let's go back to triangle K and C. K and C, from where we know that side and C, we need to find kn. So just let's have a reference for quick. So kn from there is adjacent side. So how to figure out the adjacent side? We just use, this is adjacent side, we just use opposite to adjacent is going to be tangent of 15 degrees. So from where kn becomes adjacent, so how to find adjacent? You just need to swap with tangent 15. So that's why in this case it's going to be opposite to tangent 15. So opposite is 4 over tan 15. And we can easily find that for real quick. Okay. No way. So, okay, let's do it. Kn is 4 over tangent. 4 over tangent 15. It's going to be 14.93. So 14.93 centimeters. So we've got a value for kn, and can we do that? Yes, sure, we can. Okay, we just go down. Wow, interesting. So kn, interesting working of the software. I've never seen that before. So how it works? Okay, so we know kn. It's there. It's a height. So we know adjacent side to the angle alpha. How to find angle? We use the cos rule for that small triangle. So from the triangle KLN, we're going to find cos alpha. So cos alpha, because of the given adjacent side, is going to be adjacent 5 over hypotenuse kn, which is 14.93. So it's going to be 14.93. As you can see here, there's plenty of usage of ratios, trigonometric ratios. So that's why it's all about how solid your knowledge about trigonometric ratios. That actually you need to have the skills before when you keep training on just simple triangles, on simple 2D case, okay? So 5 over 14.93, let's calculate angle itself. So angle alpha itself is going to be cos minus 1 of 5 over 14.93. And that's going to be, let's see, it's going to be cos minus 1 of 5 over 14.93. That will give you the value 70.43 degrees. Okay, so we figure out the second part of the problem, and the final value is 17.43 degrees. Okay guys, that was the complete solution to that problem. So that's definitely a tricky one. Not so, it's not like really rocket space science, right? No, definitely no. But for a GCSE student, it might be hard. Alright, so we've got angle here. Alpha is 70.43. Okay. So we figured out all the questions. Make sure you've got the same values. If not, try to compare with my explanation, then see your faults. Probably you can correct me if something wrong, but I'm pretty sure that's okay.